Right. So it will be less technical, I feel like. I will try to drive what's the motivation that we are running this project. I will explain. But of course, hopefully with enough details, but I mean, feel free to ask anything relevant. I'm going to talk about our AYA project. This AYA is kind of huge multi-institutional, multilingual instruction tuning project that we run as an open science initiative with a community part. There is a huge community part, but also there is lots of researcher involved. I think we started around January and it's almost at the end. So we are going to release data set models and stuff by the early next year. Let's start with that. So I am Ahmet. I am a research scientist at Cohere For AI. I am generally working on large language models at scale, as many of you, I assume. But more particularly, I'm working on multilingual LLMs and also efficient LLMs in that sense. So I will be happy to collaborate or chat. I just put my email here if you want to just reach out to me. So let's start with the motivation that's drive the huge project. I mean, I gathered like lots of really nice slides and presentation from different keynotes, different newspaper, blog posts, or papers. So I would like to give like a broad picture, first of all. So we have really lots of languages, right? But unfortunately, like if you look at the world, like more than 7,000 languages in the world, and around 400 languages have more than 1 million speakers, right? So this is a lot of people speaking lots of languages that our technology is not reaching. This is really like a kind of important problem for us. When we look at the NLP research, more particularly, if you look at the speakers that speak the corresponding language and the papers that's published in top NLP venues, there is extreme disproportionate attention, right? So we have some mostly Western-centric world that is generating up or like building the technology around for their own language, but also there are lots of people kind of left behind in terms of the technologies we are building. So this is one of the picture that's kind of showcasing this disproportionate technological progress. So yeah, we have like even these are in terms of language coverage is the best available. So we have XGLM. It has 30 languages in the pre-training. Bloom 45 plus 1 code languages. Also MT5 101 languages. But 101 languages is really a tiny portion of all the languages that's around that people speaking. But I would like to put this because this really showcases the problem, actually. So when we trace back the problem, where actually this problem comes from, this is because of the data. But all the data that we are using in our technologies now is based on internet use, right? So if you look at the pile, all this data is like basically web text. And if you trace back a little bit more, the reason why this Western-centric languages, mostly English, is heavily dominating all the web text, because although like 5% of the world speaks English, 63% of the internet text is actually English, because it's early using, the people speak English use early users of the internet. So this is from one of the paper that's really influential in many ways, Joshi et al. So that they also show really, kind of unfortunate but fantastic numbers, like 800 of the languages has no text available, right? This is a huge problem. But if you also look at the plot here, also the languages have some text, again, showing the same problem. Like this proportionate ratio here is super, obvious. Same thing happens in our main corpora that we are using for pre-training, or I will also show for instruction tuning, but from the beginning, these corporas that are high quality in a sense, I will also come to that point, but the text itself is extremely sparse in terms of the languages. So we have English mostly dominating the proportion, but also if you go to the tail of the languages, some of them almost has no text in it. So now I would like to go a little bit deeper as well, because it's not about only the sparsity in the data in terms of languages, but also the quality. So this is also another from my team, Julia Kratzer's work. So what they did, they look at the data and they manually audit the data to increase the quality. And what they found out, in the CC line, like 44 of the 65 languages have more than 50% of the sentences incorrect. So they need to be corrected. But if you look at the Wikimetrics, which is also heavily being used, for example, in the translation literature, 19 of the 20 languages had the same problem. So if you hire thousands of people from all around the world and try to audit every sentence one by one, you will find out that 50% of the sentences are incorrect. So why this is super important, if you think about how we pre-train the model, I mean, I think even in the pre-training now, it's coming back to quality, importance of quality, but especially for the instruction training, we have really small amount of data. Even one incorrect sentence can really influence the model very badly. And these are the data set that we are using. And so there is data set in proportion problem. When you complement this with the quality problem, actually, it is like a really big, you will see like really big problem here. Yes, grammatical errors or some like a surface level errors. Doesn't need to be grammatical, but maybe not pronunciation, but the written text has some problems. So in the paper, for example, even simple regex can actually fix loss of the data, but you need to find out that. So that's kind of the problem actually, because it's really hard to find with automatic metrics. So there are some data sets. So of course, I mean, it's not only Wikipedia or like a CCA line, also lots of people in the research area I know like trying to build the data sets. But I mean, the data set that we need is not exactly out there yet. So this is one of the example. This is really fantastic work as well. This has 300 languages, but very domain specific. This is from like a translation of some religious text. So if you use this text, probably, I mean, assuming that you are using this for large language model, your language model will generate a different kind of text that you probably won't understand with the today's language. So this is really a big problem. I mean, maybe there might be a research that you can try to convert this language to the today's language, but that's kind of orthogonal, I guess. Another thing, since this project is also kind of focused on how we create the data in one part, dataset creators are also disproportionate. So wherever you touch you will see the problem. That's why actually I want to show this kind of unfortunate picture in the beginning. So most of the, if you look at the world picture, the dataset creators mostly from the Western world, either North America or Europe. I mean, there are really few dataset creators in Latin America or Africa. So this also like reinforced problem even a bit more, because I am from Turkey, I speak Turkish, but when I try to build a Turkish corpora, it's super hard because I need to find the community around to do that. And this is really less opportunity. This is kind of similar with what I showed in the beginning, but it's a little bit more concrete numbers here now. Also with the years, with the time span. Who actually, not only the publication this time, but who is in terms of like the researchers, how this the problem also showcase itself. Lots of the researchers are from like a Western world or East Asia or Pacific or Europe. If you look at the sub-Saharan Africa, like 1% of the like NLP research done by those people. So I mean, for example, we try to convert our model, adapt our model with like super sophisticated techniques, which is really important. But if there is no one to do that, it is also a problem, right? So everything actually kind of calls the multilingual models in a way. Another metric, I like to stack all this information actually to really showcase the problem from like a 2021 NeurIPS workshop, I think. It shows some sort of geodiversity. Again, the same thing, right? North America, Europe, but less the like underrepresented countries or cultures. So when we come to a little bit more technical side, like, okay, we have this problem of the data, problem of the dataset creators, problem of the researchers, problem of the quality, what we end up. So ChatGPT is one of one of the top level model at the hand, right? At the moment, like one of the state of the art, let's say. And this paper shows that if you look at the translation performance of ChatGPT, it really outperforms the state of the art, like zero from scratch translation models in the high source languages. But if you look at lower source languages, it really falls behind. I mean, you may not really think that because, I mean, we are using now in our daily life for some languages, it really works really well for translation or for standard text generation. But if you go a little bit down and look at the tail of the language list, then ChatGPT doesn't work really well. I mean, we can see this for any downstream task. That was really interesting thing that when I was looking also what would be the results in different area. So it's not only low quality, but also higher cost because of the tokenization actually. Since these big models is not really well represented in terms of the tokens, when you try to use the APIs, you need to use more tokens and it's more cost. So it's also, I mean, the problem, right? It's really interesting complementary picture. This is also really fantastic work, I think, have been presented here or will be presented in the workshop. My colleagues here, what they did, they tried to jailbreak GPT-4 for different languages by using some translations. Maybe some of you already look at the paper. And what they find out, it is really hard to jailbreak GPT-4 in English because there are lots of guardrails, right? They build it. But if you try to do it in Zulu or Gaelic, you can be super successful because model really has low quality in very lower source languages. I mean, it's not being trained on. It's not the problem of the model, but in general, our technology really has this problem. And especially if you think in terms of the safety or responsible AI, in terms of different languages, I mean, this is like a boosting factor. And one last thing I think here, it's not about like a safety or like generating toxic content, but also factual. In terms of factuality, these models really worse in terms of lower source languages as opposed to higher source languages, right? If you look at this plot, you can clearly see like accuracy, consistency drops when you go right side of the plot. And these are not even like a generative models. These are actually more encoder-only models. Like this is more kind of a classification task. So you would expect maybe even in the lower source languages, models should perform in a degree, but still you can see the same trend here. That was the reason why we really wanted to do something with the community. So we want to build state-of-the-art multilingual generative model. I would like to clear later on what do we mean in terms of state-of-the-art. But problem is obvious, right? We see it all here. But also we think we are going through really exciting time to touch this problem and potentially at least find some pointers to solve, if not solution, but some pointers. Yeah, I know it's lunchtime, so I will be a little bit more faster now. What are these like a key points that helps us potentially to solve this problem? I mean, we all know, that's why I will be a little bit faster here. But all the LLM technologies we are building for long time, but especially for a few years that we are seeing now, kind of gives us opportunity to really touch this point and solve. What are these? Scaling. Now we can properly pre-train really large models, and they are super performant that we use our daily life. Also, after the pre-training, now a couple of few years, we see that instruction tuning plus RLHF or preference tuning really boost the performance. This is also really encouraging, I think. Now, if we have a multilingual data or high quality multilingual data actually in any of this setup, then we can really, at least have a progress. Maybe not solve, but have a progress on that. Since we have relatively less time, I will be really a bit fast because there was a kind of overview here in terms of technological progress that we have. But the main idea is now because of this bigger is better kind of race, I mean, regardless this was a good race or bad, regardless of the sentiment, what we end up, now we have really big models, is super capable, right? This was one thing. But in terms of not only model size, but also the data size and the number of tokens in our context, these models are getting bigger. So we have trying to build a larger data set. This is probably another problem later on when we don't have enough data. But we are also training model even more and more. There are optimal scaling laws, but I think the general trend is not really follow this optimal scaling laws. Just train based on your compute budget, not based on the optimality. These are the data tokens that we are training here. So everything is much more larger in terms of the scale. So yeah, I will skip this part. These are like a kind of old-fashioned pre-trained and single task fine-tuning paradigm. But I think maybe this is kind of a starting point. What we end up in like in 2 or 3 years before with the T5, or actually like a text-to-text transformation, what we learned, now we can formulate every task in one format and do the fine-tuning in multitask fashion, right? This was really kind of a big jump. Maybe not in terms of the performance, but actually this kind of changed all the wave in terms of fine-tuning. And based on that, now we have this instruction fine-tuning, right? Starting from maybe Instruct GPT or Flan or T0 paper. So there is another thing like a RLHF, fine-tuning with human preferences. I would like to only focus on this part because this is the focus that of our project. When we look at a little bit more carefully in the instruction fine-tuning, I think this part is important. When we add more diversity, more tasks, it's really improving the performance, right? So this is kind of opportunity in terms of multilinguality because we can actually reach certain amount of diversity in the multilingual data set. But this is something really that we can touch and go from there. Since now we have also bigger model, we have bigger models, instruction fine-tuning works better in the larger models. So this is also really a nice opportunity for us. I don't remember. Probably no, so let's skip because we also have less time relatively. But the point was, I think, yeah, here the point. Based on this success of instruction fine-tuning, we built lots of instruction data sets, right? Here from Flan collection paper, I think there is a really nice also list, kind of historical list of the different instruction fine-tuning data sets. We really put lots of effort, but the most of them in English. I mean, also there's Open Assistant. It's actually slightly multilingual, to be fair, but it's not enough. Also, the proportion in terms of there's a big problem in terms of the proportion. Also, like we synthetically built different instruction tuning data set, but the problem comes back. These are not multilingual and these are not really representative. There is one baseline here, I think really worth to mention. Niklas Mühlenhoff, I think in November 2022, they released the paper, this kind of a beginning paper for the multilingual instruction tuning. They take one of the instruction tuning data set, which is here P3, and they add more multilingual data in the P3. So it's become like XP3. But even for the XP3, if you look at this highlighted bold data set, these are the only multilingual data sets. So in terms of the proportion, if I'm correct, 40% of the data is English and the remaining is multilingual. And even more even bigger problem, I think here, the more diversity coming from English. So the multilingual data sets are not really diverse. So this was but this is still a starting point. When they use this multilingual instruction tuning data and fine-tune a bunch of models, including GLM, Bloom, and it become Bloom-Z and MT0, actually they get really huge boost in terms of multilingual performance, right? If you look at the orange bar, which is MT0, so instruction fine-tuned version of MT5, largest size of the MT5, they have really good performance compared to Bloom, although Bloom was a multilingual model. So now we see, okay, multilingual instruction data is really beneficial. This is our starting point of our project, actually. So where we start, this XP3. But the problem, there are language proportion, there is a problem in language proportion, but even before, number of languages are only limited, like 45 languages. Even if for MT5, which has 101 languages, the dataset itself is not covering all of them. So this is where we kicked off. So now I will give a brief overview of what we are doing in the project and like the general main steps. Then maybe a couple of few questions, and then we can close this session. So the main part of the project is collecting the data with community. So this is the part. But before even collecting the data, what we did, we take the XP3 and extend the number of languages from 46 to 101. So how we extend it? Because XP3 is template-based dataset. So let's say you have a sentiment analysis dataset and you try to convert this to the instruction based on a template, right? And when they built XP3, they only looked at particular dataset for 46 languages. So we take the same dataset without any collection, use the same templates, but this time convert for 101 languages, so that we actually first boost the number of languages by simple transformation. That was the first thing that we did. But then we figured out the quality is really big problem in XP3. So there are lots of prompt templates that are super similar. So there is almost no diversity. Then we one by one try to look at, okay, which prompt, which dataset is good or which one is not really good. Shall I continue? So this is where we clean the data. We looked at both English portion, which has more diversity, but also we looked at the multilingual portion. So at the end, these are the statistics that we end up. We actually cleaned half of the English data because half of the data was not really diverse and the quality was extremely bad. For the multilingual part, we still pruned. So by the way, the task means prompt template here, but the data set is, let's say you have sentiment analysis data set, but you have 10 prompts that you multiply the data set itself, right? So the task here corresponds to templates. So this is the second thing that we did. But now we are coming to more exciting and interesting part. Then we actually kind of leverage our community because Cohere For AI has really large community, also growing with this project, luckily. We ask everybody to contribute our project. So we built a UI. UI had two tasks. One of them is this. So we first populated this prompt and completion from the dataset that we have, XP3X, then ask people to edit the data in their own language, because the quality was the main bottleneck, right, in our dataset. Even before increasing the number, we want to increase the quality so that people look at the prompts completion, they either like a thumbs up, okay, this is really good data sample, go with that, or they flag it, it's a bad data sample, then they edit it, both prompt or completion. So actually we are now creating a new data. And the second task, after, by the way, there is a timeline. So we started with task one. First, want people to like get used to the idea, the task, instruction tuning in general, how this prompt and completion pairs are constructed. After like I think 1 or 2 months later, we launched the task two, and task two was about writing the completely natural prompts and completions. So now they every contributor pick their own language, write completely random prompt and completion. So this looks like really easy process, but it's actually very challenging because we like more than maybe I don't have like full numbers, but maybe 1,000 people really involved with that. So we, to utilize our community better, we had lots of language ambassadors. Let's say we have one Turkish language ambassador that were organizing Turkish community to do this thing better, because we really care about quality here. So at the end, this is the geographic distribution that contributed to the data. So you can see like really, I mean, it might still be relatively disproportionate, but now we have huge diversity. This is one of the big success that I think we kind of have here. So these are some numbers that contributed. So Asia, you can see Africa. So these are relatively, I mean, not all Asian languages, but generally there are more lower source language in these areas rather than Europe or Latin America, but we have a really huge number of contribution here, which is a really good sign. And if you look at the top 10 languages in our like a scoreboard, because we make it a little bit like a gamification. So we had weekly top 3, top 10, monthly top 3, top 10, and things like that. So all these languages, especially like if you look at the top 3, for example, these are really underrepresented languages, right? So this is something that really we wanted to do, and it seems now we have some sort of data here. In terms of the quality, just to show some like a material metric here, one thing what we notice in the instruction tuning dataset, the completion length is really important because, for example, I will go a little bit back, but here MT0, if you look at the performance and the benchmarking performance, it seems best, right? And it's quite high. But if you try to generate something with MT0, you cannot do that because the dataset itself was organized in a way that like answers are mostly yes, no, true, false. So it was not really generating. I will also show some examples. That's why we start from there and we thought, okay, maybe we should push all the contributors, at least encourage all the contributors to generate longer sequences, longer completions. And this was one of the quality metrics in our agenda. And as we get more contribution, more data, if you see here, we have larger completions. So this is, I mean, longer completions. But also with the thumbs up and thumbs down, we have this some sort of quality estimation. And if you look at these 3 plots here, when we have a longer sequences in terms of prompt completion or combined, quality also increasing. So people are actually also not only contributing, but also confirming that, okay, longer sequences are better. Also over the time, because this was a learning procedure for all of us, this quality in the form of length was also improving. So this is how we collect the data. What we will do early next year, probably January or February, we will release 2 sets of data. One is called AYA dataset. This is exactly the dataset that I show, how we collect directly with the edits and people's natural prompts. This will be one thing. And the other thing is something slightly bit different, similar with XP3. So we also let our community members to generate prompt templates for particular dates. Let's say you have Mafant Indian language translation data, but this is not instruction, right? But it's not formatted in terms of instruction. And people speak those languages, build the templates, and this way build the data set. So this will be the second part of our data release. We call it a collection. At the end, all the data, as we kind of hoped, will have 101 languages. All the procedure, like 9 months or so, I think, more than 1,000 people involved. So it was really a huge effort, I think. Let me see the time. Is it finished? I guess, kind of. Yeah. Yeah, so yeah, we have preliminary experiments, not the complete results, but I mean, I can maybe skip evaluation very quickly and show some preliminary evaluation metrics just to showcase it's really working. It's not like trash data set. So the base model is MT5. And the baseline, we take MT5 and fine-tuned with this XP3X, like a not contributed dataset, but the first stage of the dataset. We call it MT0X because it has 101 languages. And this is one of the intermediate models. So because we just finished the data collection today. So this model, I think, trained maybe 2 months ago or so. But of course, just to check the progress, we have some metrics here. These are from discriminative task, completely held out, like XNLI, XCOPA, XStoric loss, all these data sets. We have kind of important jump in terms of middle and lower source languages. This is really something promising. I wouldn't trust completely discriminative task if I don't show any generative task, by the way. That's why I put here also Flores. This is now we have like a both English to X to English as well, except the lower source languages, which kind of showing some sort of limitation here. But also the middle resource language bucket is the larger bucket. We have kind of huge jump. This is also a nice sign. But also we kind of wanted to see how the generations are getting better or not. I think this is slightly bit important in terms of our hope. So this is exactly what I say. Even in English, MT0 was like, if you ask what are 5 ways to eat apples, this is a sample taken from Dolly dataset, by the way, and not inside the training data. And this is the output you will get with MT0, which is kind of state of the art in terms of the language coverage. But now our intermediate model was working not perfect, but much better. And also in Turkish, when there is non-English language problem, actually two-sided, because not only short generation, but also some loss of time, incorrect language. But with our intermediate model now, at least we kind of solved this incorrect language in a large portion. And now also we have a slightly bit better generation. I mean, not the perfect. Also, I cherry-picked those examples, to be fair, but much better than the baseline. So I would surely say that. So yeah, in 2 months or so, we will have big data set. We will release open source models trained with those data sets. That's the project. And I would like to finish with like, because lots of people really involved all the procedure. I would like to cheer all of my collaborators here. Yeah, that's it.